This video is about general diagrams in mathematics. For diagrams in the category theoretical sense, see diagram. Mathematical diagrams are diagrams in the field of mathematics, and diagrams using mathematics such as charts and graphs, that are mainly designed to convey mathematical relationships, for example, comparisons over time. A complex number can be visually represented as a pair of numbers forming a vector on a diagram, called an Argand diagram. The complex plane is sometimes called the Argand plane, because it is used in Argand diagrams. These are named after Jean-Robert Argand, although they were first described by Norwegian-Danish land surveyor and mathematician Caspar Wessel. Argand diagrams are frequently used to plot the positions of the poles and zeros of a function in the complex plane. The concept of the complex plane allows a geometric interpretation of complex numbers. Under addition, they add like vectors. The multiplication of two complex numbers can be expressed most easily in polar coordinates. The magnitude or modulus of the product is the product of the two absolute values, or moduli, and the angle or argument of the product is the sum of the two angles, or arguments. In particular, multiplication by a complex number of modulus 1 acts as a rotation. In the context of fast Fourier transform algorithms, a butterfly is a portion of the computation that combines the results of smaller discrete Fourier transforms into a larger DFT, or vice versa. The name butterfly comes from the shape of the data flow diagram in the radix 2 case, as described below. The same structure can also be found in the Viterbi algorithm, used for finding the most likely sequence of hidden states. The butterfly diagram shows data flow diagram connecting the inputs x to the outputs y that depend on them for a butterfly step of a radix 2 could lead to key FFT. This diagram resembles a butterfly, as in the morpho butterfly shown for comparison, hence the name. In mathematics, and especially in category theory, a commutative diagram is a diagram of objects, also known as vertices, and morphisms, also known as arrows or edges, such that when selecting two objects any directed path through the diagram leads to the same result by composition. Commutative diagrams play the role in category theory that equations play in algebra. A Hasse diagram is a simple picture of a finite partially ordered set, forming a drawing of the partial order's transitive reduction. Concretely, one represents each element of the set as a vertex on the page, and draws a line segment or curve that goes upward from x to y precisely when xy, and there is no z such that xzy. In this case, we say y covers x, or y is an immediate successor of x. In a Hasse diagram, it is required that the curves be drawn so that each meets exactly two vertices, its two endpoints. Any such diagram uniquely determines a partial order, and any partial order has a unique transitive reduction, but there are many possible placements of elements in the plane, resulting in different Hasse diagrams for a given order that may have widely varying appearances. At each crossing we must indicate which section is over and which is under, so as to be able to recreate the original knot. This is often done by creating a break in the strand going underneath. If by following the diagram the knot alternately crosses itself over and under, then the diagram represents a particularly well-studied class of knot, alternating knots. A Venn diagram is a representation of mathematical sets. A mathematical diagram representing sets as circles, with their relationships to each other expressed through their overlapping positions, so that all possible relationships between the sets are shown. The Venn diagram is constructed with a collection of simple closed curves drawn in the plane. The principle of these diagrams is that classes be represented by regions in such relation to one another that all the possible logical relations of these classes can be indicated in the same diagram. That is, the diagram initially leaves room for any possible relation of the classes, and the actual or given relation can then be specified by indicating that some particular region is null or is not null.